So how do we use the similarity measure in calculating the similarity degree between the new case and the old cases? In calculating the similarity measure, we do have two types of similarity. We have a local similarity that is named as LS and the global similarity known as GL. In a local similarity here, we are using a local similarity to calculate the similarity between the features attributes of the new case to the old cases. Meaning that in a local similarity, we are calculating the similarity between the attribute values of the new case with the old cases, while the global similarity is a build-up from the number of a local similarity. Meaning that in a global similarity, we are comparing the build-up of similarities for all feature values of the new case to the old cases. So the local similarity is calculated between each attribute values of the new case to the old cases, while the global similarity is calculated to find the similarity degree between the cases by comparing the build-up of the similarities for all attributes values of the new case to the old case. So here is the relationship between SL and a global similarity, where the LS is representing a local similarity. So for example, LS1 is representing similarity degree for the feature value 1 of the new case to the old case, and LS2 is representing the similarity degree for the second attribute value of the new case to the old case, and so on of LS, while the global similarity is built up from the number of the local similarity, meaning that it is the weighted sum of the similarities for all features values of the new case to the old case. So in calculating the local similarity, we have two types of formula that can be used. We have a numerical or continuous value, and we have a discrete value. Here is the formula for a local similarity for a continuous category, where the similarity between the attribute value A of the new case and the attribute value of the old case is equal to 1 minus the absolute value of A minus B over the ring. So what do we mean by the absolute value here? Meaning that we don't care about the negative outcome of A minus B. So for example, if the value of the attribute A is equal to 3 and the value of a B attribute is equal to 4, so will be 3 minus 4, definitely we will have minus 1. But since we do have an absolute here, so it will be, the outcome will be 1. That is what we mean by the absolute. So in this formula, you have to know that A is the attribute value in the new case, B is the old attribute value in the old case, while the ring here is the value of the difference between upper and the lower boundary of the set, meaning that the ring can be expressed with the equation where the ring equals to the maximum minus the minimum value. What do I mean by the maximum and the minimum here? We mean the maximum and the minimum value of each attribute values in the set of the all cases. So I'm very sure that you are wondering how we are going to implement this. So don't worry, we are going to implement these equations along with the rest of the equations that we are going to discuss in the next slides in the tutorial where we are going to implement a CBR in the case study. And here is the local similarity for discrete value where it can be expressed as the following. Similarity of the attribute value of the new case A to the B, which is the attribute value of the old case, if A, which is the attribute value of the new case, is equal to B, which is the old attribute value of the old case. If they are equal, so the similarity degree will be 1, while if A is not equal to B, meaning that then the similarity degree will be 0. So you have to be sure that A always represented the new feature, meaning that the new attribute that exists in the new case, and B is the old feature, the brief old features, meaning that the features that exist in the old case. So after calculating the local similarities, which can be calculated by measuring the similarity degree for all features values of the new case to the old cases. So then it's a time for us to calculate the global similarity that is represented as a build-up of the local similarities. So where with the using global similarity, we will be able to matching which case from the old cases are more similar to the new case. So in the global similarity, so the formula for global similarity that can be used here it is, where it can be expressed as a following: the similarity between the new case, which is A, between the new case, which is A, and the old case, which is represented as B, is equal to 1 over the summation of the weight. Weight of what? Do you still remember when we said that in the previous slides? Each attribute or feature of the case will have the importance. This importance we are name it as the weight. So here is the weight of the attributes. We remain here to the attribute that is indicated to I. So here is the weight of the attribute I, then multiplying by the weighted sum of the local similarity, which can be expressed as the summation of the weights of the attribute I multiplying by the similarity of I attributes, which can be expressed as a local similarity that are calculated for attribute I, which we can read it as a similarity. A local similarity for attribute I is calculated by calculating the similarity between attribute value of I of the new case, and B here is the attribute value for the I in the old case. So after retrieving the more similar cases to the new problem from the case base in the case retriever phase, the reuse cycle is activated with the aim of reusing the solution of the retrieved cases. But let us raise a question here. How to adapt the solution? In adapting the solution, we do have a different option that are available for us. We have an options of no modification to the solution of the retrieved problem, meaning that If the new case is found to be same as the retrieved case, so the solution of the retrieved case are directly used as a solution for the new problem. This can be done by just copying the solution of the retrieved case and put it as a solution for the new problem. The other options is related to the manual solution adoption by the user, where the new case is found to be quite similar to the retrieved cases. So we need to adapt the solution of the retrieved case to be fit to the new problem. And in this option, the adapting of the solution is executed by the user. The other options is related to the automatic solution adaptation, where the adaptation of the solution is executed by using a certain automatic methods such as transformational analogy, where we do the transformation of the solution, or the derivational analogy, where we need to replay the problem solving trace. And the third solution adaptation is compositional adaptations, where we combine the several cases to the single solutions. You don't really need to know in details how the automatic solution adaptation is executed, but if you are interested, you can search. So the output of the reuse cycle is the proposed solutions. So the proposed solutions will go to the revise cycle. In revise cycle, we aim to revise the proposed solution that we obtain from the reuse cycle. So in the revise phase, how do we revise the proposed solution? We revise the proposed solution by verifying and correcting the solution. So we are making sure and verifying that this proposed solution is correct. In revise phase, there might be no revise for the proposed solutions, and we also verify the solution or evaluate the solution by using a computer simulations or by implementing these proposed solutions in the real world. But how do I know this proposed solution need to be revised or need to be verified or not? What are the criteria for the revision? Here are the criteria for revisions. We have the correctness of the solutions, where it's related to the matter of the solution to be correct or not. And the second criteria is the quality of the solutions, and another criteria that is related to the user preferences. So the output of the revise phase is the conformed solution. So the conformed solution will go to the retain cycle. So we already know that the retain cycle, in the retain cycle, we are storing the new problem with its solution in the case base. What are the things that CPR can be learned here? Different types of things that the CPR can learn. So for example, the new experience, meaning that the experience here is the new cases that are added into the case base. Also, CPR can improve the similarity assessment based on the calculation of the similarity measures that we have done in the retrieval phase, and also can also learn the knowledge for the solution adaptation that has been conducted in the reuse cycle. Another thing is forgetting the cases where there are some cases that are out of a date, meaning that the very old cases that has been stored from a long time that is considered to be out of a date need to be deleted. So the methods in a written case is first storing the cases in the case space, meaning that storing the new case in the case space, deleting the cases from the case space where we delete the cases that are considered to be out of a date in order to enhance the efficiency of the case spaces and retrieving the most similar case.